Okay, so let's get back to answering this question. We want to find the exact value of sine of alpha plus beta. All right, so notice that we have addition here. Let's go ahead and break this up using our sum formula for sine. All right, so I'll remind us. Here's the sum formula for sine. So we need to take sine of alpha times cosine of beta plus cosine of alpha times sine of beta to be able to solve this. All right, and we actually know all of these things because we drew the appropriate triangles in the right quadrants. All right, so sine of alpha, well, we were actually given that, but we could use our triangle. 5 over 13. Cosine of beta, so we want to make sure we go to our beta. All right, that's 5 over 6. We were also given that one. Cosine of alpha, we need to use our triangle with alpha. All right, so that would be 12 over 13. Noticing that we're in the second quadrant, cosine is negative in the second quadrant. So it's going to be negative 12 over 13. And then sine of beta, so we're back down with this one. Okay, that is root 11 over 6. And sine is negative in the fourth quadrant. So it's going to be negative root 11 over 6. All right, now we just got to multiply and add. 5 times 5 is 25. 13 times 6, not sure, calculator. It's 78. Negative 12 and negative root 11 is 12 root 11. 13 times 6 is 78. So final answer, 25 plus 12 root 11 over 78. All right, so we had to do a couple things. We had to use our sum formula, but we also needed to write out our triangles in the appropriate quadrants. Okay, all right, let's do another example. All right, I think someone asked me, could these problems get more complicated? Only a little bit more complicated. All right, so we want to find the exact value of the following. All right, let's see. We got sine of arctangent of negative 9 over 4 and arc cosine of 8 over 17. All right, so again, let's think about what we're working with here. Arctangent and arcsine are angles. So two angles added together is another angle. All right, so we're really just finding sine of theta. Our theta just happens to be broken up into two angles. I'm going to call them U and V, just so they match our formulas. All right. So if this is U and V, that means the problem that we're asked to answer is actually just sine of U plus V, right? Our two angles. That means we can use our sum formula. All right, so before we do that, let's go ahead and, actually I'll write out the sum formula. It's sine of U cosine of V plus cosine of U sine of V. So that means we have to figure out sine and cosine of U and V. So how do we do that? Let's start with U and V. All right, so U is given by arctangent of negative 9 over 4. We know exactly what this means. That means U is arctan of negative 9 over 4. That's equivalent to saying tangent of the angle U is negative 9 over 4. Okay, that means what quadrant is U going to be in? It's either going to be in quadrant 1 or quadrant 4 because that's where arctangent angles are found. We know it's quadrant 4 because tangent is negative. right, so tangent is opposite, so that would be our 9 over adjacent, that would be our 4. You can put the negatives where appropriate or save them for later. This says u right here, by the way. All right, then we just need to find the third side. All right, so let's see, 4 squared plus negative 9 squared equals c squared. So c is square root of 97. All right, that's the first part. We figured out information about u. We got our triangle. Almost done. Now let's move on to v. So v is going to be given by arc cosine. All right, and so this tells us that cosine of the angle v is 8 over 17. All right, and so that means it's going to either be in quadrant 1 or quadrant 2, but since cosine is positive, we're in quadrant 1. So our angle V can be represented inside of this triangle, where the adjacent side is 8, the hypotenuse is 17, and we can figure out the other side. It's 15. Okay, so we've set up our problem. We figured out these are two separate angles. We found out all of the information we could possibly need about our two separate angles. Now we can answer our question, all right? This big thing we have, I'm just going to rewrite everything. We have rewritten it as sine of u plus v, which tells us we can use our sum formula for sine of u, cosine of v, plus cosine of u, sine of v. And then we can use our triangles to find the exact values of those trig functions. So sine of u, so that means we need to go to our u triangle. All right, sine is opposite over hypotenuse, 9 over root 97. We're in the fourth quadrant, so sine is negative. Then we need cosine of v. We can use this one, which we're given, but it's adjacent over hypotenuse. First quadrant, everything is positive. Cosine of u, that means we need to go back to our triangle with u in it. Cosine is 4 over root 97. In the fourth quadrant, cosine is positive, so this should be positive. Sine of v, we're going back over here to v, opposite over hypotenuse, should be positive because we're in the first quadrant. Okay, now we just multiply across. All right, negative 9 times 8 is negative 72 over 17 root 97. 15 times 4 is 60 over 17 times root 97. And then negative 72 plus 60, that's negative 12 over 17 times root 97 is the final answer. Okay. All right, and finally, we're back to verifying identities, and we're going to use our sum and difference identities to do that in the next video.